From the dawn of humanity, gemstones have captivated us. Their vibrant colors and inherent brilliance set them apart. Ancient civilizations attributed mystical powers to these stones. Diamonds, with their unmatched hardness, symbolized strength and invincibility. Emeralds, with their verdant hues, embodied life and renewal. Royalty adorned themselves with gemstones, signifying power and prestige. Crowns glittered with rubies, believed to possess protective energies. Sapphires, in their celestial blues, adorned rings and necklaces thought to bring wisdom and good fortune. These gems transcended mere adornment. They became woven into the fabric of our shared human story. These stones, formed over millennia deep within the earth, became tangible connections to the planet's history. Each gem, unique in its imperfections, holds within it a record of its creation. The swirling patterns in an agate, the inclusions in an emerald, these are nature's fingerprints, proof of their long journey from the Earth's core. Today, as we stand at the cusp of technological innovation, our fascination with gemstones continues. But alongside these treasures of the earth, we now have a new generation of gems, lab-grown alternatives, identical in composition yet born from human ingenuity. The allure of natural gems has always been intertwined with their rarity and cost. Diamonds, particularly those of significant size and quality, command staggering prices. A 2-carat diamond formed over billions of years can easily fetch tens of thousands of dollars. This high cost is a reflection of the gem's journey, the geological processes that created it, the labor-intensive mining, and the expertise required to cut and polish it to its full brilliance. Lab-grown gems, on the other hand, offer a more accessible entry point into the world of sparkle. A lab-grown diamond, chemically identical to its natural counterpart, can be produced at a fraction of the cost. This affordability is largely due to the controlled environment in which these gems are created. Without the need for extensive mining operations, the cost of production is significantly reduced. This difference in price does not necessarily diminish the beauty or desirability of lab-grown gems. In fact, many argue that a lab-grown gem, created with intention and precision, can hold its own against the allure of a naturally formed stone. The choice ultimately comes down to personal preference, budget, and what one values most in a gemstone. The value of a gemstone is determined by several factors. The 4 C's: cut, color, clarity, and carat are key in assessing a gem's worth. The cut dictates how well a gem reflects light, impacting its brilliance. Color, from fiery reds to deep blues, adds allure. Clarity measures internal flaws or inclusions. Some inclusions add character, others detract from value. Carat, the unit of weight, correlates with size and value. Beyond the 4 C's, origin and market demand also influence price. A gem's origin can significantly affect its price. A Burmese ruby commands a higher price than others. Market demand, trends, and endorsements also play a role. Ultimately, gemstone value is a mix of objective factors and subjective perceptions. The global gemstone market is experiencing a period of robust growth. Driven by a confluence of factors, this billion-dollar industry is projected to continue its upward trajectory in the coming years. One of the key drivers is the increasing demand from emerging economies. As disposable incomes rise in countries like China and India, so too does the desire for luxury goods, including gemstones. This surge in demand is creating new opportunities for both natural and lab-grown gem producers. Another significant trend is the growing emphasis on ethical sourcing and sustainability. Consumers are becoming increasingly aware of the environmental and social impact of mining and are seeking out gemstones that are ethically sourced and conflict-free. This shift in consumer awareness is driving demand for lab-grown gems, which are seen as a more sustainable and ethical alternative to mined stones. Technological advancements are also shaping the gemstone industry. Innovations in lab-grown gem production are resulting in higher quality stones that are virtually indistinguishable from their natural counterparts. These advancements are making lab-grown gems an increasingly attractive option for consumers who prioritize quality and affordability. Section 5. The Environmental Equation: Mining's Impact and Sustainable Solutions. The extraction of natural gems, while an integral part of human history, comes at an environmental cost. Mining operations can disrupt ecosystems, pollute water sources, and contribute to deforestation. The quest for these treasures from the earth can leave behind a trail of ecological damage if not carried out responsibly. The use of heavy machinery, the disposal of mining waste, and the energy required to extract and process gemstones all contribute to the industry's environmental footprint. Moreover, the transportation of gemstones from often remote mining locations to cutting and polishing centers around the world further adds to their carbon footprint. However, there is a growing movement within the mining industry towards more sustainable practices. Responsible mining companies are implementing measures to minimize their environmental impact, such as reducing water and energy consumption, rehabilitating mined-out areas, and investing in community development projects. Consumers are also playing a role in driving demand for sustainably sourced gemstones. By choosing gems that have been certified by reputable organizations such as the Responsible Jewelry Council, consumers can support ethical and environmentally sound practices within the industry. Section 6. Ethical elegance, ensuring responsible sourcing. Beyond environmental concerns, the ethical sourcing of gemstones is of paramount importance. Conflict diamonds, also known as blood diamonds, are those mined in war-torn areas and sold to finance armed conflicts. These stones have fueled human rights abuses and instability in various parts of the world. To combat this issue, the Kimberley Process Certification Scheme, or KPCS, was established in 2003. This international initiative aims to prevent conflict diamonds from entering the mainstream diamond trade by requiring participating countries to certify the origin of their rough diamonds. However, the KPCS has faced criticism for its narrow definition of conflict diamonds, which does not encompass diamonds mined in countries with poor human rights records or where labor exploitation is rampant. As such, there is a growing movement towards more comprehensive ethical sourcing standards that address a wider range of social and environmental issues. Consumers can play a vital role in promoting ethical sourcing by asking jewelers about the origin of their gemstones and demanding transparency and accountability within the supply chain. By making informed choices, consumers can help create a more just and equitable gemstone industry. Section 7. Natural gems, pros and cons. Natural gems formed over millennia deep within the earth hold a unique allure. Their rarity, the result of specific geological processes occurring over vast stretches of time, contributes to their value. Each natural gem is unique, its internal inclusions and imperfections telling a story of its creation. For many, the appeal of natural gems lies in their connection to the Earth's history. These stones are tangible reminders of the planet's immense power and the intricate processes that have shaped our world. Owning a natural gem can be like owning a piece of geological time. However, the mining of natural gems can have significant environmental and social impacts. From habitat destruction to human rights abuses, the quest for these treasures can come at a cost. Additionally, the supply of natural gems is finite, and as demand continues to rise, prices are likely to follow suit. Section 8. Lab-grown gems, pros and cons. Lab-grown gems, also known as synthetic or cultured gems, are chemically identical to their natural counterparts, but are created in controlled laboratory environments. These gems offer a number of advantages, including affordability, ethical sourcing, and environmental sustainability. Because lab-grown gems are not subject to the vagaries of natural processes, they can be produced in larger quantities and with greater control over their characteristics. This allows for more competitive pricing and makes these gems accessible to a wider range of consumers. Furthermore, lab-grown gems are not associated with the ethical concerns that plague the mining industry. They are conflict-free, and their production does not contribute to human rights abuses or environmental degradation. This makes them an appealing option for consumers who prioritize ethical considerations. However, some argue that lab-grown gems lack the romance and mystique of their natural counterparts. They are not products of nature's slow and unpredictable processes, but rather of human ingenuity. As such, they may not hold the same sentimental value for some individuals. Section 9. The future of sparkle. A glimpse into the evolving gemstone market. The gemstone market is poised for growth and evolution. Consumer preferences for ethical sourcing and affordability boost lab-grown gems. Technological advancements will enhance lab-grown gem quality. This will blur the lines between natural and lab-grown gems. Natural gems will always hold a special place. Their rarity and unique imperfections captivate collectors. The future involves coexistence of both natural and lab-grown gems. Prioritize ethical sourcing and sustainability in the gemstone industry. Informed choices ensure these treasures bring joy for generations.